Today we're going to take a look at the equations of circles. By the end of this video, you should be able to graph a circle from standard or general form, and you should be able to write the equation of a circle in standard or general form. First, let's take a look at a cone. If you take a cone and slice it so that the slice is parallel to the base, the cross section is a circle, as you can see here. You should all know what the sketch of a circle looks like. The standard form for equation of a circle is something that you should have seen in geometry. That is x minus h squared plus y minus k squared equals r squared. And we see circles a lot in everyday life. A wheel is a circle, a clock is a circle, gears are circles, and ripples in a pond are circles. First, let's take a look at a couple definitions. A circle is the set of all points in a plane that are equidistant from a given point called the center. Any segment whose endpoints are the center and a point on the circle is called a radius. And we have two different versions of the equation for a circle. The first is the standard equation that you saw in geometry, x minus h squared plus y minus k squared equals r squared. And in this version of the equation, the point hk is your center and r is your radius. The general equation is a bit more complicated. You would have a x squared plus b y squared plus cx plus dy plus e equals 0. And you would know that this is a circle if a and b are the same number but not 0. So the general equation is a little less user-friendly, but you do need to be familiar with both forms of the equation. So let's take a look at a few examples. First, we have an equation, x minus 3 squared plus y minus 2 squared equals 16. We need to find the center and the radius and then graph this circle. One important reminder, because the formula is x minus h and y minus k, the negatives are already included in the formula. So h is just 3 and k is just 2. So our center is 3, 2. Our equation is equal to r squared, which means that the radius is going to be the square root of 16, which is 4. So from the center, I want to go 4 units up, 4 units down, 4 units to the right, and 4 units to the left. And then I can sketch in the circle. And that is the graph of our equation. Now we're going to start with an equation in standard form and change it to general form. And if you remember, general form, the equation was all written out, not in parentheses squared. So that means that we need to multiply out these squared terms. So if I have x minus 3 squared, just a reminder that that means you are doing x minus 3 times x minus 3. So if you double distribute and combine like terms, you end up with x squared minus 6x plus 9. We can do the same thing with y minus 2 squared. That would be y minus 2 times y minus 2. And if you double distribute and combine like terms, so then if we put these together and keep it equal to 16, we then need to combine our like terms and set this equal to 0. So I have x squared plus y squared minus 6x, minus 4y plus 13 equals 16. And then I need to subtract 16 from both sides so that this is equal to 0. So if I subtract 16 from both sides, this is my final answer, the equation of that circle in general form. And if you notice, earlier we said that a and b, which are the coefficient of x squared and the coefficient of y squared, have to be equal to each other and not equal to 0. And you can see that we have one x squared and one y squared here. So we know that this is the equation of a circle. Now, this is the trickiest part. If you are given an equation in general form and you want to rewrite it in standard form, we are going to have to complete the square twice. So I'm going to start by grouping my x terms together and grouping my y terms together. And then I'm going to go ahead and add this 8 to the other side. Now, if you remember from Algebra 2, when you complete the square, I'm just going to focus on the x's for a minute. You need to take b, which is the coefficient of x, in this case negative 8, divide that by 2, and square that value. So if we have negative 8, divide by 2, we get negative 4, squared is 16. So I'm going to add 16 to both sides of our equation. Now I'm going to do the same thing with the y terms. I'm going to take b, which in this case is 2, divide that by 2 and square it. Dividing by 2 would give me 1, squared is 1. And I'm going to add 1 to both sides. Then I need to factor the x part of the equation. And this would factor to be x minus 4 squared. And do the same thing with the y terms. And then I would add up all of the numbers on the other side of the equation, which would give me 25. So this would be my equation in standard form. Now, let's look at problem number 4. I have an x squared term and an x term, so I can put those together, and I'll add a blank for when I complete the square. And then I only have a y squared term. I do not have a y term. So that actually makes it easier because I do not have to complete the square for the y's. So if we look at the x's, if I take b, which is negative 4, divide that by 2 and square it, I get 4. So I'm going to add 4 to both sides. And then I do not have to complete the square for the y terms. Now I'm going to factor the x terms. Bring down the y term. And add my constants together. So this would be the equation in standard form. Let's take a look at 2 more problems that require a little bit more thinking. For number 5, we want to write the general equation for a circle that has a center at 2, 3 and contains the point 5, 6. Well, it's hard to go straight to the general equation, so I'm going to start by writing the standard equation. I know that my center is 2, 3, which means my equation is going to be in this format, but I don't know what r is yet. So there are 2 ways you can think about this problem. You can either take this point and plug the 5 in for x, the 6 in for y, and solve for r that way. Or if you're more of a visual thinker, you can graph these points, and then you'll end up having to use the Pythagorean Theorem or the distance formula, which are essentially the same thing, to figure out the distance between those points to figure out what r is. I'm going to do it the algebraic way, and I'm going to plug 5 in for x and 6 in for y. 5 minus 2 is 3, squared is 9. 6 minus 3 is 3, squared is 9. So I end up with 18 as r squared. And I'm going to stop here. The reason I can stop here is because I'm going to have to put r squared in my formula. So if I take the square root, solve for r, get a radical, I'm going to have to square it again when I plug it back into my formula. So I'm just going to stop there. So I end up with my standard form equation of x minus 2 squared plus y minus 3 squared equals 18. Because it asks for the general equation, I'm going to go ahead and multiply these out. And I'm not going to show all of my work this time because I can do a little bit of this in my head. If I square x minus 2, I end up with x squared minus 4x plus 4. And then if I square y minus 3, I get y squared minus 6y plus 9, and that is still equal to 18. So when I combine my like terms and set it equal to 0, I end up with x squared plus y squared minus 4x minus 6y plus this would give me 13, and if I subtract 18 from both sides, I get minus 5 equals 0. So that would be my general form equation. Our last problem for today, all we know about this circle is that the endpoints of the diameter are 8, 0 and 0, 6. So I'm going to go ahead and plot those on this graph, 8, 0 and 0, 6. And those are the endpoints of the diameter. What we need to do is find the center and the radius. Well, the center is the midpoint between these 2 points on the diameter. So you can either use the midpoint formula that you learned in geometry, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Or you can just count it out. If I count, I have to go over 8 and up 6. So if I do half of those, over 4 and up 3, That should be my center. So my center is 4, 3. Now for my radius, I can do the same type of thing that I did on problem number 5. You can either do the algebra to figure out what r is, or you can use the Pythagorean theorem. I'm going to show you the Pythagorean theorem for this problem. If I'm looking at the distance from the center to one of the points at the end of the diameter, I know that I'm going over 4 and up 3. So my radius would be the hypotenuse of that right triangle. And that would mean that r squared is equal to 4 squared, which is this side, plus 3 squared. When you go ahead and do that arithmetic, you end up with r squared is equal to 25. And I can go ahead and stop there. You can see that this is essentially the same thing that we did in problem number 5, it's just a different way of thinking about it. So if I first write out my standard form equation, I have my center, and I know what r squared is. So I have x minus 4 squared plus y minus 3 squared equals 25. And if I want to go ahead and write this out in the general form, I need to square x minus 4, which would give me x squared minus 8x plus 16. And I need to go ahead and square y minus 3, which would give me y squared minus 6y plus 9. And that is still equal to 25. So when I combine my like terms and set it equal to 0, I end up with x squared plus y squared minus 8x minus 6y plus 16 plus 9 would give me 25, but when I subtract 25 from both sides, I end up with 0. So that would be my equation in general form for a circle with endpoints of the diameter at 8, 0 and 0, 6. One last thing I want to mention. The work that I have shown is the minimum amount of work that I want you to write down. If you need to write out a few more steps, that is totally fine. I know that on problem number 5 and problem number 6, I was able to square those binomials, primarily in my head, but if you can't do that yet, then just do like we did on problem number 2. Go ahead and write out the binomials, double distribute, and combine like terms. Again, on problems number 5 and 6, I did quite a bit of arithmetic in my head to get the final answer. If you aren't there yet, that's fine. Do like what we did in number 2, where I combined all my like terms and then subtracted to make it equal to 0. But do not show less work than I have shown, or you will probably make some silly mistakes.